This problem will show us start to finish how to graph a parabola. When I start off, I will always factor this first, because when I factor, I'm going to get the solutions to this problem, meaning my zeros. If I factor, that will show me where my parabola is going to hit the x-axis. If I were to think about a parabola here, my y values are 5, 4, 3, 2, 1. This is where my y equals 0. So if I want to know the x values, where on the x-axis does my parabola hit, that point here and that point here would be the places where the y equals 0. So if I want to know that, I would say y equals 0, and I could solve using the skills that I just learned on on yesterday's lesson, or Monday's lesson, 8.1.6. Let's try it. Using my factoring shortcut that I just learned, I need two numbers that multiply to 5 and add to 6. I can do this because that number out front in front of x squared is a 1. Two numbers that multiply to 5 and add to 6. 1 times 5 is 5, 1 plus 5 is 6, so I have my two numbers. If I want to know where the x's are, where the y equals 0, I have to say that 0 is equal to those two factors. I have to set them equal to 0 individually. If x plus 1 equals 0, and I solve, oh, x equals negative 1. That's one of my answers. That's one of the x-intercepts. If x plus 5 equals 0, same thing, x equals negative 5. Using that information, I can plug those numbers into the table right away. If my x equals negative 1, I know that my y is going to be 0. If my x is negative 5, my y is going to be 0. I can go through and I can actually plug in each number here and solve. I can plug in my negative 4. And when I solve that, I get negative 3. And I can go through one by one here. I can also plug those into my graphing calculator. Either way, if you go through and do those, you might want to pause right now and do them on your own, put them in your graphing calculator. But if you don't pause, here come the answers. Spoiler alert. That's what you would get. The whole point of this example is to graph your quadratic equation. So we're trying to graph this original guy here. What would that graph look like? And how can I factor and analyze so I can see some important parts of what the graph of that would look like? Later on, we'll learn about why that's so important. Negative 5, 0. At negative 5, I'm going to plot the point 0. At negative 4, I have a negative 3. And then those are the first 5 points I have. I can connect this with a parabola. My favorite thing is that this looks like a mouse, kind of. Yay, it's so cute. I love it. Cute, cute. And now that I have everything graphed, I can answer some of these important questions. So my x-intercepts, where it hits the x-axis, that's at negative 1, 0, and it's also at negative 5, 0. And for my y-intercept, that is at 5, 0, 5. Because I could plug in x equals 0 here into my original, and if x equals 0, that means y equals 0 squared plus 6 times 0 plus 5, and hey, what do you know? That means that your y value would be 5. Now, it says to make a connection, where are the x-intercepts? The x-intercepts are in your factors. You can see your x-intercepts quickly by setting your factors equal to 0. And your y-intercept, that's the last number. When you write it in standard form. If you think about standard form being called, if you write your equation as ax squared plus bx plus c, that c term, that one at the end, that's your y-intercept.